Homework 10, question number 2. For question number 2, we have to collect the definition of property of different kind of stochastic processes. The first one is wide sense stationary process. So a wide sense stationary process means a stochastic process is called wide sense stationary process if its mean is constant and autocorrelation is a function of time difference. The second one is independent increment process. So a stochastic process is called independent increment process when the independent increment process mean x of t1 minus x of t2 and x of t3 minus x of t4 on a non-overlapping interval are independent. The third one is Markov process. We say a process x of t is Markov process if the past has no influence on the future when the present is known. The fourth one is normal process. A process x of t is said to be normal if the random variables x of t1, x of t2 till x of tn are jointly normal for any n and any t1, t2 till x of tn, that is function of x1, x2 till xn and t1, t2 till tn is equal to 1 by 2 pi root n to the power that e to the power minus half n minus x transpose into C inverse n minus x. The fifth one is short sense stationary process. A process is said to be short sense stationary if its stability is not affected by a shift on the time axis. So you can write this one as function of x, x1, x2 till xn and t1, t2 till tn is equal to function of y, x1, x2 till xn and t1 plus sigma, t2 plus sigma till tn plus sigma. White noise. White noise for a awareness process Wt if we wish to discuss the derivative Vt is equal to dWt by dt. So we have the mean of white noise is equal to dE Wt divided by dt equal to 0 and the autocorrelation is Rv T1 T2 is equal to alpha lambda T1 minus T2. So when a process Wt does have a derivative, we use Vt which is equal to dWt by dt just as notation. The seventh one is mean ergodic process. A stochastic process x of t is said to be mean ergodic process if limit t tends to infinity 1 by 2t which is integration of minus t to t x of t dt. We can write this one as e of x of t. So this is the mean of ergodic process. So if the stochastic process satisfies this condition, we can call this is a mean square. Eight. Martellings. A stochastic process x of t is said to be Martellings if e x of t given x of s equal to n, which is equal to n, where s must be less than equal to t.